Hi everyone, this is just a quick update of a test that have underway at this time. It's a very simple test. I didn't have to change anything really in the circuit. You're looking right now at one of the 6 batteries that I have, and right now what I've done is I've got 3 batteries in series. So as you see, this is tying the batteries, and this is my positive lead going into the circuit, and my negative is here, and this 2 leads here are my high quality multimeter here, and I'll show you the numbers right now. So that battery bank there is giving us a total of 39.5934, around that range. So all these digits here are points, so it's 39 volts, 0.59, and I have all these extra digits here to see very accurately what's happening to a battery, and that was one of the reasons I got this meter here. So right now the circuit is functioning, so this 39 volts there is going through the circuit right now. And on this side of the circuit I have the identical batteries there, and I have 3 of them in parallel. So these 3 are in series and these 3 are in parallel, and the circuit at this time is maintaining the batteries on this side at 12.99 volts. So it's not going down from that. It's been running now for about an hour and a half, probably even close to 2 hours. I'm not keeping very accurate data, it's just a quick test. So hey, here you even saw it go up to 13 there. So anyways, it's not dropping from that, and I have a continuous load on these batteries. This light bulb here, which is a 120 volt light bulb, it's something like a 7 watt 120 volt light bulb. It has a high resistance. It's just to see what happens, with a load. And what I've done is I tuned the circuit. I've adjusted the duty cycle. Let me click back to my scope here, and this is the 555 pulses there, and there's the data on it there. We're at 10 kilohertz. I found it seems to work very well at 10 kilohertz. And we're at 12.6% duty cycle. So that 12.6 duty cycle was adjusted so that we maintain our voltage here with these 3 batteries in parallel with this load continuously on it. Alright, so I'm finding this quite interesting because we're not having that much of a voltage drop here. So we're still at 39.59 there, and we've only dropped these finer digits here, and we're maintaining this battery here. Obviously, again, I'm not making this up. What I report is true. I don't exaggerate things. So that's maintaining continuously. That those batteries are continuously being charged, and a load is attached to it there. And like I said, the circuit is tuned to maintain that that voltage there. So what I can do quickly is just stop the circuit and measure, like, let's say any one of these batteries, and just attach that bulb, and you can see how much the voltage will drop from there. I'll do that right now. I'll just pause the camera here and I'll attach it. Actually, before we even do that, let me just take this lead here and check the voltage across this battery right here. Alright, oops. So if we look at that battery, we've got 13.26. Alright, so we've got okay, so we got that 13.2689. Alright, and it's, you know, slowly maybe working its way down there. All right, so the circuit is still functioning, and that's what we have across that battery right there. So what I'll do now is I'll stop the circuit, and our bulb is still running. We still have our voltage maintained here at these battery banks with the bulb. And I'll just attach the bulb onto there, just this single battery instead of the 3 in series. And we'll look and see how much our voltage will drop with that bulb. Now it should drop, you know, obviously more, you know, than what it is here, because here it has the other 2 batteries. And, you know, I find it interesting because you'll see that it's dropping quite a bit. So let me pause the camera and I'll attach the bulb there. So we're at 13.2687. So as soon as I stop the circuit, what I'll do, I'll just disconnect this lead here from the input here. And now you can see the voltage, okay, climb back up. So we're at 13.30. All right, instead of 2.6. All right, so the circuit's not functioning, and here we're starting, see, to go down right now. The bulb is still connected. All right, so what I'll do now is maybe I can even do this with the camera going. So let's put the bulb on this side here and see what happens. All right, so we're at 13.3. All right, I'll connect that up. And look at that. Look how quickly that is working down. That's within seconds. I'm saying that this is working down faster than 3 times. It's very interesting. Look how quickly it's working down. Okay, and there's the bulb. Same brightness as it is here, because we still have about 13 volts, right? And it's connected basically just to this one here, to that single battery there. And look how quickly it went from 13.3, or when it was actually under load at 13.26. Okay, and it's now at 13.17, and still very fast, working its way down. So anyways, I thought I'd post that, and because it's kind of interesting to see that. And here our batteries have restabilized because the load isn't on it there. So, and these are all in parallel, and again these are in series. And here's a last look at the bulb, still on it at 13.16, and still continuously knocking itself down very fast. So I'll continue doing this test here and see how long anyways, what's happening is I'm finding really good results with the extra voltage here at the front end, and it doesn't seem to be taking much amperage from the batteries. And with the batteries in parallel here, that was a suggestion from 0.99, and I think he was bang on to have this side here in parallel. And anyways, this is the test so far. One more look here at our dropping voltage, and that's about all for now. So thanks for watching, and we'll give you an update a little later. Bye.